Hi there, and welcome to another episode of Mr. Ed Codes. And in this episode, I'm going to be doing a continuation of my series where I look at classic arcade graphics from the 1980s into the early 90s and try to replicate those animations and effects using a modern language like p5.js. Just a little background, I started programming basic in middle school back in the 80s. So I was immersed in that when it was happening. And now I'm almost 50 years old, and I like going back, and you know how old people are. We go back and look at the good old days, as we call them. May not have been the good old days, but it's different than what is now, and it's just nice to compare and contrast. So looking at modern computer games, they're hyper realistic, super immersive, like total reality experience. And then back in the 80s, it's a box moving around the screen. It's a pie that looks like its mouth is open. I mean, you had to use a lot of your imagination, but still, even though you had to use a lot of imagination, these different graphics were really charming and they had some allure, and it was interesting how you could create something that will stand in or symbolize what we're really familiar with by using a handful of pixels. It's just incredible to me. So I want to continue that in this series. The previous series did paratroopers. In this one, I imagined a case where the paratroopers are landing on water. So they fall into the water, and maybe they inflate a raft and float around, or sharks come after them, or they just swim there, or sink, or whatever it is. I wanted to create that water, and I wanted to create the ability for an object to float on the water. So let me load an example here so you can see what I'm talking about. Here where I attempted to put it in to just see what it would look like. So let me jump over here, take a close-up look of what's happening. So this is the paratroopers example that I did in a previous video. You can find that here. I made a more basic version than this. This is a really advanced version. And in a later episode, I will go through this code with you. If you want to learn how to do this, I'll go through it line by line, and you can have this as well. But I wanted to create the water, and I wanted them, instead of falling through the water and restarting, I wanted to create another series of animations where the object would inflate a raft and then float around on the water. The first part of that problem is just creating water waves, and creating layers of those, and then trying to figure out where your object is going to be in those layers, and then getting the information from the wave to give it to your object so that it knows how it's floating, where it should be. So all that stuff's kind of complicated. What I ended up working out was this thing here. I'll load it for you. Just to make it interesting, I put a clock on there, but this could be anything. Meet Bob. Bob is a bobbing box, and I call him Bob because it's easier to keep in my mind, and it makes it easier to code. So when I code this for you, and you guys can follow along if you want, you can see Bob show up a lot of times in the code in reference to this object here. So I have lots of layers. There's like this volume. The layers are scaled so that the waves in the back are kind of low and subdued, while the ones in front are really dramatic, and it just gradually changes as it goes back, along with the color, the shade, and the waves in front of this object block the object, so it looks like it's submerged, and then the object's blocking the layers behind it, so it looks like it's actually setting in the volume. As well, the object rotates, looks like it's being like knocked around by the waves, and it goes up and down relative to the wave layer that it's, I guess, floating on, or looks like it's floating on. And it displays the time. Why not, right? So if you guys want to learn how to make this code, I'm going to go through it line by line. Here you can see I've annotated it here. All right, well, let's just jump into this program. Let me not make the same mistake twice. This is twice I've done this now. So I'm starting over with this video because I left it on the screen while I'm typing the program out. All you're doing is watching a blank screen. So let me make sure I'm on the right screen. And let's go to close-up type. we're going to do a new window here. New sketch. So I'll explain everything as I go through it. I won't redo this program the way that I did it. I started small and then got bigger. So the very first thing I started was with the wave. Once I got a wave made, I made multiple waves. Once I got multiple waves made, I figured out how to get them to stack on the screen. Once I got that done, got them shaded, got their waves scaled. Then I figured out how to get Bob to float on top of them. So it was just step by step. But instead of going through all that with you, which takes a long time, I'm just going to go through this line by line and explain what each line does, and hopefully by the end of it we'll have this program written. So the first and obvious thing that we need are some global variables, and those will handle the information that we transfer between Bob and the wave. The wave is going to be sending some information back to Bob, and we need to handle those globally so that they can pass around the program without any problems. I could use the instance variables instead of using global variables, but I wanted it to be more simple in my head. So global variables help me do that. I don't have to remember what element it is or what index it is. I don't have to remember what the object name is or what variable I pass that object. I don't have to remember any of that. So the very first thing is tell p5.js that water is an array and it's going to be holding our objects. p5.js doesn't know it's going to be holding our objects. It just knows it's an array right now. But I'm going to have it hold objects later on. We need to know how many layers of these water waves are we going to print on the screen. I could hard code that into the loop, but I wanted a global variable that I could adjust. I need a variable to hold which layer Bob is floating on, and so that this information can be passed into the function, and then the function knows, do I need to look at this layer when I'm making layers of water? Do I need to look at this layer because this is the one Bob's on? If Bob's not on a layer, I don't want to have to look at it specifically. I'll just make it. So that's what floatL is going to do. It's going to inform the wave layer object where Bob is at. I changed the screen from day to night. It's constrained. It's constrained between 75 and I think 200 or something like that. What the variable is, it's related to the saturation of the color variables. So in the background you've got your red, green, blue and your alpha. If I just set that to an oscillator that moves back and forth from 75, goes up to 200, goes from 200 back down to 75. If I just do that back and forth, it's going to make it look like it's day and night. So that's what D2N is, day to night. How fast is it going to change time? That's what this variable does. Okay, so these are the variables that handle Bob's horizontal position, his vertical position, and his size, so he's scalable. Bob's size, I don't think I really use this variable. I mean, it's used, but it could be more functional. What do I mean by that? Well, right now Bob's fixed in the center, and I'll show you how I do that later on. But he's fixed in the center of the volume. I could make it where he could float to the background, so he moves from from one layer to the other. So he can move to a 4-layer or a background layer. When he does that, he needs to get bigger or smaller so that the perspective is represented. So in order to do that, I have a variable called Bob size. And then in order for Bob to move from layer to layer, I need to be able to handle that. So float Z handles that. That could be a noise value. So float Z could be another one-dimensional noise value that handles how he moves to and fro. Right now I have him fixed at the center of the volume in the program that I showed you. But so far as we've written this program, he's on layer 3. Now I initially set the layer to 1, and now I'm setting the noise value to 3. Later on I'm going to take float L, whichever layer he's on, and I'm going to make sure it's halfway between however many layers I have. So that's going to get more complicated. I'm old school. I like to, when I declare a variable, assign it if I possibly can. And if it's a weird variable, I definitely want to. So showtime isn't a numeric variable, although it doesn't really matter. Showtime is going to be a string and numbers. I'm going to construct it from a number of things and then use that in the text statement to display the time. The xoff handles the noise. So if you look at the noise wave function in the examples at the p5.js website, you'll notice that it has this variable called xoff. It's x offset. In order to get the wave to look like it's moving, so you're not printing the exact same wave every frame, you have to cycle through those numbers, through that noise. So you want to offset it just a little bit so that it gives you that persistence of vision look that there's actually waves. BobX handles that. So I think I got all of my global variables, hopefully. Holy cow, look at all those. Let's come down here and do... So I'm not even ready to deal with the background yet. We got a lot of stuff to do before. Let's finish setup. So I want window width, window height, just so we can see whatever's available, we can use it. If I didn't put this initial position for Bob's Y, if I didn't set it down to where the waves are probably going to be printed at, on the first frame you're going to see Bob at the very top of the screen for just like a flicker, one frame. And then he's going to fly down to the bottom really fast. The next frame he'll be at the bottom. I don't want that flickering. I want him to start where he needs to be, or close to where he needs to be. So I'm going to start Bob's Y initial condition will be 75% of the height. So down the screen, 75% is roughly where Bob is going to start at. This is where the waves are, they're in that range. So about 75% of the height is where the waves start, I think. Yeah, 75% to 65%. So the lowest position of a wave, of the middle wave, or not even the middle wave, I think it'll be the first wave, the starting wave. Whatever layer is in front, that's your wave number 1 or wave number 0. Wave number 0 will be constrained. It'll be at least 75% down the screen to 65% down the screen. Does that make any sense? Probably not. I'm not even sure if it made sense in my own brain, but that's what I said. I'm sticking to it. I don't like division. I get too many division by 0 errors that way, so I just want to multiply times a fraction if I can. So float L, whatever layer Bob is floating on in this volume of layers. So the volume of layers is layers 0 through however many you have. And I want him to be in about the center layer, the center of those. So if I take my total number of layers and divide by 2, create the integer or the floor value of that, it's going to put him roughly in the center of those layers. So there'll be waves that roll in front of Bob, there'll be waves rolling behind Bob, is the goal. Now we're ready to instantiate. Let's create our loop. That's going to be number of layers long, less than the number of layers. In a previous video, I was so wrong about this, and it was obvious the second I rewatched the video. If you have this set less than or equal to, then whatever number is set for number of layers, you're going to have to add that 0 to it. So ultimately, you're going to have one extra element. Then the number value for the number of layers. So what you do is you less than number of layers. So 0 through 1 less than that is going to be however many you want. You're not going to have one more than you want. If I put equal here, then I'm going to have, how many layers do I have? 8 layers up here. See, number of layers is 8. So down here, it's going to go 0 to 8, which is 9 layers. I think I said that correctly. But if I do this, it's going to go 0 to 7, which is 8 layers, which is how many we want. I understand in principle why they start out an array on 0, because that's what you should do. But conceptually, that 0 throws things off. I mean, half the people who celebrated the new millennium were off by a year because of that reason. And then, you know, the smart asses out there, they're like, it's not the new millennium yet because there was the year 0. It's like, no one cares. No one cares about the year 0 and doing that. It doesn't make sense. I mean, it does eventually, but it's not a very intuitive thing. Do you guys get that? I sure do. It messes me up all the time. Obviously it did. I told you guys the wrong thing in the video last time. If I do, I'll try to fix it later on. Just understand that I have a problem with language and understanding things. So why shouldn't you be instructed by me, right? In spite of that, I'm still able to pull shit out of my ass. So there's that. Okay, hopefully I have cut that part out of this video. So I'm using the water variable that I made up there, the array. And p5.js knows it's an array, so when I want to push something new into it, it's just going to go to the end of that. If there isn't any, it's going to go to the start, and it's going to create a new element in that array. That's what this is for. What is going to be in that array is the object water wave, which is tied to a function that we haven't made yet. And I want to pass into it which water wave are you making? In other words, which layer are you making? And that's going to be important later on because I want to know which layer Bob is on so I can pass the right variables to Bob so he knows where he needs to be. Just to be officious, I'm going to put rectangle mode right there just so I know that it's done and I don't have to spend time wondering why stuff's not being displayed correctly. I think we're ready for our draw now. If you guys are still typing along, hopefully you are. I put a clock on Bob just so he'd be interesting. So in order to do that, I need to grab the hour from the p5.js keyword hour, and I'm going to set that to the variable h, and I'm going to do that with minutes. Because I'm using this in draw, and because of the type of assignment it is, I can use a let there. I don't have to use a global variable and then do this. It's okay. It'll be alright if I put let there. Sometimes it's not. This has been explained to me by numerous people, and I sort of understand the mechanics of it, but I don't really understand the language of it. So I don't want to explain. I want to use words that aren't right, trying to explain to you what's happening with the let and the vow and declaring and assigning global variables, instance variables. Whenever you get the minutes from p5.js, it might be like, say it's 2 minutes past the hour. It's going to give you a 2. So if you're going to put that in a string where you have the hours and then you have a colon and then you have the minutes, that minute is going to be messed up. It's going to be whatever hour it is, colon, and then 2. We're all used to it being 02, right? 03 all the way up to 09. I need to put that 0 in there if it's less than 10 so that it looks like time. That's what this line is doing right here. So if m is less than 10, it's going to add a 0 to the front of that. Do the same thing for hours, except for this is a little different case. Hours comes in 24-hour time, so if it's greater than 12, I just want to subtract 12 from it. But that will give me a 0 in some cases. So I'll just test for that case, and if it's a 0, I'll make it a 12. Easy breezy. So now you have a nice looking time. Now all you have to do is just put all that into a variable, and then you can just print that variable. Oops. So it's building showtime. Showtime is going to be whatever h is. Then there's going to be a colon, and then whatever m is. And if m needs to change to add a 0, it's going to happen. If h needs to change to make it a 12 instead of a 0, it's going to happen. And if the hours is greater than noon, it's not going to be 13 o'clock. It's going to be 1 o'clock. So all that's taken care of. Bob's moving back and forth, and he's doing that with Perlin noise. So I need an offset so that it will move through those values. So I use Bob X off as my offset for Bob's one-dimensional noise to move back and forth. Here's where I increment or decrement the time depending on whatever polarity. So if this is a positive number, it's adding to the time. If it's a negative number, it's subtracting from the time. And I need to check and see if it's past those constraints. So if it's greater than 200, which will be the top constraint, or if it's less than 75, which will be the bottom constraint, I'm just going to flip the polarity of time pass so that instead of incrementing, it'll decrement, and if it's decrementing, it'll increment. I also want to create Bob's noise, and that's going to be a value from 0 to 1. I'll just multiply it times the width, and that will give me a range of it moving back and forth within the screen. Okay, I think I'm ready to adjust the background now. I have some variables I can do that with. So I want it to go from blue to dark blue or something in that sky blue range. So I'm going to use green, a lot of green, and I'm going to use maximum amount of blue, so that'll be the top value there. So it's going to be mostly blue looking, but you're going to have a little bit of a green there if things especially get layered and stacked. This day to night is going to get subtracted from these values. So when it's nighttime, I think, oh no, flip it. When this is its lowest value, it'll be daytime. So when this is 75, it's going to be daytime. When this is 225 or 200, it'll be, because it's constrained, then it'll be nighttime, because it's subtracting 200 from this 225, subtracting 200 from this, so that the blue will be a saturation of 55 at night, and it will be a saturation of 255 during the day. So Bob's size is going to be scaled to whatever layer he's on. So if Bob moves to the back, he's going to be smaller. If he moves to the front, he's going to be larger. I can just map his size to whatever layer he's on. And I think that's what I do here. So float Z. You know what I think originally, this actually isn't working because Bob's layer is fixed. So Bob's size is going to be fixed. So this really isn't going to be doing much in this program, but it could be. And originally I had it tied to the time of day. So during the night, maybe it was closer up, and during the day it was further back. And it would come to and fro depending on the day. So it's moving through the layers depending on what time of day it is. If that's constrained by 75 and 200, and my Bob size goes from 10, so in the middle of the day he's the furthest back and the smallest size, and at night he's the closest and the largest size. This is just relational to the size. I also have to do the layer moving, which involves float Z, but I don't do that. If I want to in the future, those variables are there. So, and I just left them here in the example because you might want to use them later on, and it wasn't too bad to explain it. So a lot's going to be happening inside this loop. A lot. The first thing we want to do is check and see if the layer, so we're drawing the layers. I guess the first thing I should explain is this loop is going to be making the layers of water. And when we get to the layer that Bob is floating on, then we want to do some checks. And if it's true, then we want to display Bob. And then if it's not true, we want to display the water layers. We're doing it in a certain order, so that the background layers are printed first, and then if Bob needs to be printed somewhere, he's popped on there, and then the top layers are printed, so that everything is sandwiched nicely and Bob looks like he's floating or embedded in the volume somewhat. So to do that, I need this condition here. I need to use that variable float L, which is the layer that Bob's on. And if the layer that he's on is equal to the number in this loop, then I know he's on the right layer. So now I can draw Bob. Oh, wait a minute. I need to do a push and pop here. Get everything to look good and do what it's supposed to, so I don't have to constantly backspace. Translator. How about translate? Oh my God, seriously? Is it just going to do this? I'll explain all this here in just a second. Okay, so what's happening here? Inside push and pop, I'm going to encapsulate a number of changes to the graphics attributes. So I'm going to rotate and translate, and I want those transformations to only happen within push and pop, so they're not going to happen globally. I want the objects to be centered, or I want the origin to be around the center of the object. So I'm going to translate the origin to Bob X and Bob Y. These are the horizontal and vertical positions of our floater, and that's going to be related to the layer that it's on. It's not yet, but it will be. What's messed up with this? Why do I have that? Oh, I need another parenthesis right there. Okay. And then I'm rotating by pi times Bob's X position, and then a really small number. So it's not going to be rotating a whole lot. And Bob X is tied to Perlin noise. So you look up here, we have Perlin noise. So it's going to look like Perlin noise rotation too. So it's going to look really organic. I could make up my own another noise variable for how it rotates, but it's not really necessary. So I want to fill that object with black. That's a lot. So I want the stroke to be a little bit brighter than the bright and on the red side, I guess, is the whole point of this. You can mess around with those and make it however you want. I just did it so that it would contrast a little better. I'm using the day to night number, this variable, because it's changing. So the stroke color will change as the day and night changes. It's not going to stay the same. However, the fill color will change the same. And I could adjust that. I could put day to night here, and then the fill color would change to green, depending on what time of day it is. I should use Bob's size here. I'm just going to hardcode 50 for now. I'll put Bob's size in there after I get everything working. Program for you. But Bob's size should be represented here. I have 10 tacked on the end as a fifth variable in rectangle. What that will do will round the edges with a 10 pixel radius circle. So like the edge of a circle that's 10 pixels radius, the corner of the rectangle will be softened to the edge of that curve. Could have just copied this into there. I think that would have made life so much easier, but that's all right. You know me, I like doing things a hard way, just because it makes life interesting. No stroke around our time. And that's what we're working on right now. This is going to be creating the time that's printed on Bob. I want it to be at the top of the box a little bit so that it's turned upside down and under the water and impossible to see unless it's transparent. Okay, I think that's it for that. Oh, wow. We're getting there. We're finally making headway. So that's the end of the condition. So if we're on the layer that Bob is floating on, then we want to print Bob, and that's what we did there. Next, we want to create the layer, the water layer. So I'm making Bob first, and then I'm making the water layer. But if Bob's not being printed, it's not going to matter. So Bob will always be kind of embedded in the volume that way. Remember, don't do what I did and spent a good 10 minutes looking at what the problem was. Don't do this. p5.js doesn't know what the hell you're talking about. It needs to know what the index is. You're only omitting the index value if you want to look at that object, like in a console log, or if you're instantiating it with a push into, where did I do that at? Have we made that much? Like, right, this is the only time you really don't want to use the element, the bracket with the element value in there, because p5.js knows already and it's adding it to the end of the array. But if you're cycling through the array, well, then you need to tell it which element it's on. So be sure, I'm telling myself this more than anything, be sure to put this in there or you're going to run into problems. It's not going to know what render of, it can't run render because of, it doesn't know what it is. This is the error you'll get. I can't remember exactly what it's called, but that's what it is. And that should be the end of our loop. So we're at the end of draw. Wow, that draw has a lot in it. Okay. But it needs it all. If I probably should have put all that in its own function, but it works in there. It's okay. I don't know why I do that. Maybe force a habit. I always put a semicolon. It doesn't matter what it is. Semicolon at the end. We're making the function water wave. So I'm taking the noise wave example from the p5.js website and just modifying it to make it a function so I can create lots of different waves. So I need some of those variables that's in the example. Those need to be instance variables. I call them instance variables. If that's not the name, I'm sorry, but that's what makes sense in my head. It might be, but I don't know. Probably has another official name. I've probably read it 50 times and I still can't remember it. Okay, so these are our starting variables for when we instantiate our wave. This is what it's going to be set up with. So I want the y offset to be scaled. So the waves behind, they're not just duplicates of one another. The wave behind is offset a little bit, and the wave behind it is offset a little bit. So it looks like the waves are moving from the foreground to the background, or the background to the foreground, and that it's an actual volume. So I do that by taking the index value, and since the index value can be 0, I don't want to multiply times 0. I always want to multiply it by at least 1. So I'm going to take I and add 1 to it, and then multiply it by whatever fraction I need to create the offset. The x offset can start at 0. It's fine. And the wave height, it's 30. So this is going to determine the distance between the top of our wave and the bottom of our wave. And I think it's also factored into how they're stacked. It may not be, but I think I thought about that at one point, so we'll look and see if that's true. And then we're assigning the wave x an instance variable to Bob X and Bob Y, which are global variables. I didn't have to pass those in. They just exist already globally. The reason why I'm doing that is because I would rather work with those as being instance variables. It may be just so I could keep track of what was being worked with in the instance and what was being worked with globally. So I can keep those separate. If I made changes to one, it would happen globally and I wouldn't have to do that inside the function. It's hard telling. I'm sure whatever reason I did it for, it was overthought and superfluous. There we go again with that damn semicolon. Okay, so I'm going to make a method in my water wave function. I'm going to call it render, and render is going to do all the updating and everything. I don't want to have two separate, like update the wave and then make the wave, because the waves, I don't know, they're not really, it didn't seem like I needed to do it that way. And I can't really explain to you why you would do a separate update method and then a render method, why you would keep those separate. There are good reasons why, but I couldn't find one in this case, so I just didn't do it that way. This is so extra. I don't even know. I couldn't even probably explain to you what is going on here. That damn I plus 1. It took me a long time to, it's like, why is that happening? I can't figure out why it was happening like that. It's because it was multiplying times 0. It was throwing everything off. Oh, wow. That's a nightmare. I'm just going to copy that over. I'm sure I missed a parenthesis somewhere. So I should have 0 as red. And then in green, I need the quantity. I need the quantity of 255 minus the quantity of 1 plus I times 10. So order of operations, it's going to figure this, it's going to multiply that times 10, and it's going to subtract that from 255. And then from that, it's going to subtract our day to night value. And it's going to do the same thing down here. What am I missing here? 255 times, I think I have something extra. 255 minus 255 times, do I need that parenthesis? Okay, let's just figure it out in our head. So, yes. Otherwise, it would just multiply 1 times 0.25 and then add I to it. I don't want to do it that way. I want I and added to 1, or 1 added to I. And then I want that value multiplied times 0.255. And then I want that value multiplied times 255. Or did I say 255 here? 0.25. Then I want that multiplied times 255. So basically what it's doing is producing a small fraction based on what layer it's on. And then it's going to subtract that fraction from a maximum saturation. It took me a long time to figure that out because of that add 1. And then it got so convoluted I couldn't figure out. I was trying to duplicate it in other places and I would miss things, and I was like, you know what, just copy this from there. Just copy this from there and it should work. And it did. I don't know what I was missing, but I was missing something. The stroke weight is pretty simple. It's a fraction of I. A fraction of whatever layer number it is. Okay, so I'm not doing that again. Let's just copy this. Okay, so just whatever your fill is, make that the stroke. And I think it's slightly changed. There's a couple value changes here because I want it to be a little bit higher in saturation than the fill. So I'm going to change that from a 5 to an 8. So it's 285 instead of 255. And I guess I don't do it for, yeah, don't do it for the alpha here. In fact, take this off the alpha. So that's what your stroke should look like. So we have a condition for the green, or we have this formula for the green, formula for the blue, maximum saturation, no red. You can see why people, when you're programming, you just start with like white, black and white, or gray. And then you get everything done with that way. And then you work on the colors, because sometimes adjusting the colors can be way extra. So in the render, I want to create a shape. And that shape is going to be a polygon, sort of, with the waveform on one side of it. So the sides are going to be straight, the bottom's going to be straight, the top is going to be the wave, and the inside is going to be filled, and the shape is going to be closed. To do that, I'm going to use the Vertex, and the example, the noise wave example on the p5.js website uses the Vertex keyword. So you're basically just duplicating that little program. So you want, instead of x off, you're going to use the instance variable, this dot, that we declared up there in the setup of our function. So we need to reset the x off, so we're getting the same set of values. They're just offset by the y a little bit. We need to go through all of the x's from the left to right for as wide as the screen is, and we're going to step 10 every frame. So a loop from the left-hand side of the screen to the right-hand side of the screen. We're moving through the x's that represent that, and we're stepping 10 every time we go. So in order to work with this loop variable, I just put it in the instance variable, this dot. It's not coming to me exactly why I did that now. I think I did this last night. Maybe it'll come to me, but right now it's not, but I'm sure there's a good reason. Or it seemed good at the time. You can put this all on one line. I'm breaking it up just so I can see it better. And you guys can see it better. And I can explain what's going on better. And that's the wave height. Okay, so here's our noise variable, and we're going to map the noise to y, so we get this nice range of noise. Let me use my mouse here. That's the one that's controlling one dimension of noise. That's the x. This is controlling the y dimension of noise, which is making the wave look like it's going up and down. So that up and down is tied to the x, left and right. So basically the up and down random number knows where it's at because of that x offset. It knows where it's at, and it can relate the next set of random variables. If you just change that a little bit, it'll look relational, and then you get the nice wave action. Probably doesn't make any sense, probably the worst way to explain noise, but that's how it made sense in my brain. That value is 0 to 1. What noise returns is 0 to 1 value. I think I'm missing a parenthesis right here. Yes. So x off, comma, y off, end parenthesis, because this is a map, because we're dealing in the map function, that's why you have noise is the first variable in the map. That's going to return 0 to 1, and then you're going to multiply that, or it's going to factor that into here. So 75% of our height to 65% of our height, and depending on what layer it is, it's going to be factored with the wave height and its layer number, so that those waves will be smaller as it goes back, larger as it's forward. So now that I have my variables that I need, I can actually create the vertex that's going to be a part of this wave shape. Because I need to scale it, depending on which wave it is, I need to put those scale values in there. So the y value here, the vertex is pretty much going to be the same, the x part. The y is what's really going to change to scale. I guess I could change this by adjusting this here. It's not really necessary. The amount of pain that I'd have to go through to do all that isn't worth the payoff. You can't really notice it that much. So I'm not going to go through that much pain. I'm just going to leave it the way that it is. So the X fidelity isn't scaled as you go to the background. You don't get more X units and then fewer X units as you get to the front. It's the same number of X units from front to back. Only the height of the wave is really kind of changed. I think optically, if your brain is set up to look at it and it looks like it has some perspective, then that effect is going to make the foreground waves look as though they're spreading out as they go into the distance, like they're getting larger and spreading out into the distance. So it can your brain can make sense of it without asking too many questions. So it's not worth programming all of that nightmare for very little payoff. We are so close to finishing this program you don't even realize. So I want to look inside when it's making the wave. So it's making this layer and it's going from the left to the right, and every time it does, it picks a new X position and it goes up or down depending on the noise. When it gets along that X position and it meets up to where Bob is at, that's when I want to do stuff. So I need to look and see, has it met up? Are you where Bob is? If you're where Bob's at, then I want to assign the Y position for this wave to Bob's Y position so things make sense. So that's what I'm going to do here in this condition. And because everything is scaled, you have to be sure to keep that consistency. Otherwise, Bob's going to be floating above the water or underneath the water or at the top of the screen. So you have to be consistent and make sure that's all correct. Okay, I think it is. So now we need to finish off the shape. So we've started the shape, we've created the wavy line, we've dropped out of that loop, now it's done, I think. Is it? No, the loop's not done till right here. Oh, I guess I got it right here. Here I go again, putting too many brackets in. Let me make sure. This should be the end of the for next loop, or the for loop. That's the end of the render. There's my for. Is that right? I guess I need a bracket here. This needs to be the end of the for next. And this can go away. This needs to be, that's the end of the render. That's the end of the condition. That's the end of the for next. I shouldn't have that there. Oh, okay. That's, all right. That's not making sense to me. I'm like, we should still be in this loop. This loop should still be here. It should be happening. and the begin shape is outside of the loop, and the end shape should be outside of the loop. So this should be the end of that. Okay. I got to keep that shit straight. I'm wasting way too much time keeping track of the brackets, and it's frustrating. And it's confusing you guys. So we figured this out now. This is the end of the condition. Yes. This is the end of the loop. I'm at the end of the loop. I've went through all of the little X's for the waveform, and I'm outside of the loop now. So now that I'm outside of the loop, I can move my X offset over a little bit. So the next time I go into the loop, I'm going to get a slightly different waveform related to the one before. So unless your screen width is a perfect multiple of 10, the end of that loop is not going to end on the width of the screen, or it's not going to be on the right edge of the screen. It's going to be off a little bit. And then when you draw a line from that point to the bottom corner, you're going to get a diagonal. It's going to look weird. So what I'm doing here is I'm tying that last X, the furthest right X. If it's not on the screen, doesn't matter if it is. If it's on the side of the screen or if it's off the side of the screen, doesn't matter. I'm going to draw a line from it to the side of the screen just to make sure that it happens. And then I'm going to draw a line from there to the bottom right hand corner, then a line from there to the left hand corner, bottom left hand corner, and then just close the shape. And I should get a rectangle with a wavy top. So this one handles the last X to the right edge of the screen. This is going to handle the lower right hand corner. This is going to handle the lower right hand corner. And it's vertex, not vertexed. I do that a lot. I just start typing TX and T comes out at the end whether I like it or not. So I can end this shape now. And I should have two. I'm missing a bracket. So this should be the end bracket there, right? No? What am I on? Why does it do that? Okay. That's the end of my render. Yep. This is the end of my loop. The end of the condition. Okay, I think I've got them all. Cross your fingers. You think we typed in everything correctly? And we did, sort of. I can see that there's some issues. The color of the waves didn't quite come out correctly. I must have missed something there, so I'm going to double check that fill variable. Given how complicated it was, it stands to reason that it is messed up. So I've got 0, quantity 255 minus I plus I times 5 minus 2 day to night. Same thing here, minus, okay, is that the wave? Yes. Times 10 minus, okay, 255 minus 255 times the quantity of I plus 1 times, that's it right there. Let's change this to 1. See if it makes a difference. Yes, that's a little bit better. All right. That's what you should see if you've typed this in and you've somehow suffered through all of this insanity. This is what you should have. So we've got our volume of waves, several layers, and this is set up so you can change. You don't have to have 8 layers. You could go to that number of layers variable there and you can change it to 5. See, a little bit different. So what do you think? Is this something that you might add to a program an classic arcade style program, I think it has a lot of potential for stuff going on here. I mean, it looks cool, and it, how many times have you seen water or something water-like in a video game, an old video game? So I think there'll be plenty of chances for you guys to use this code or use something like it in your arcade programs. And if you do, leave me a comment, let me know where I could find that out. I would love to see it and figure out what you did. All right, thanks for joining me for this episode. If you've typed this in and you've found success, congratulations. Thank you for watching the video and allowing me to show you how this was done. That's just a privilege. I feel really privileged to be able to do that. And I just wish there was something out there like that for me when I was first starting out, that I could go out there and watch these examples. And there were some, but there wasn't enough. I watched all those and I wanted there to be more. So if you're one of those people that want there to be more examples of simpler programs that are easier to do in like in half an hour or an hour, but are really powerful and you can use those in so many different ways, if that's something that you're into, then I'm glad I could do that for you. And that's exactly what I'm doing. That's what this series is about. And thank you for joining me for that. And as always, until next time, take care.